Hello, everyone. Welcome back. Today we're going to finish 11.3, charting a budget. It's the second day. I decided to split it up. So last time we were here, we created and used budget checkoff chart. And today we're going to expand a little bit more on our second learning objective here, which is going to be to visualize and interpret a budget using a circle graph, which we did last time, but more specifically today, a bar graph, a line graph, and a budget line graph. So get strapped in, get it popping, let's go. I was feeling a little silly when I was making these slides, so be prepared to hang with me, Ms. Passmore. Yeah! All right, so we are talking budgets, people. So I'm just going to recap a little bit and throw in some visuals here. This is like a strictly visual slide. So last time we were here in section 11.3, which is charting a budget, right? We talked about our budget check off graphs. This is the one that we were talking about for like health related items, where it's literally just categories, length of time, check marks, just to give you a nice visual representation of when expenses are occurring, not necessarily how much. And we talked about the pros and cons of that. Then we upgraded a little bit and we ended up coming up with just this classic budget chart, which does in fact have values in there. So we talked about the perks of that as well. This is still for health information. Then we talked about the circle graphs, aka pie graphs, and specifically for like transportation and things like that. Obviously, looking at this, you can see that a little bit over 50% of the budget for this individual is fuel, insurance, and repairs. You can make different inferences based on this information. This is how a lot of people start to categorize like how much their budget goes to something, like within the categories. It's a nice way to visually see how much you're spending in each particular category. And then bar graphs is what we're going to be talking about today. So here's just a random bar graph I found off the web, spending at a glance, since we're talking about expenses and budgets and things like that. And these might be something that goes into your budget, such as home, transportation, health, charity or gifts, subscriptions, daily living, entertainment, savings, obligations, miscellaneous, yada, 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 right? You guys have seen bar graphs, histographs. They're all over the place. They're probably the ones you're the most comfortable with creating, and we will work with those a little bit today. Additionally, we're going to work with these are line graphs. So this is just for months of the year, income versus expenses. That's a really great way to compare line graphs. I don't think the example we're doing today does that. We're just creating a line graph given a particular situation, but this overall is a really, really great idea because you can see how much larger your income is versus your expenses. So then you can start to save a bunch, or you can notice trends like the months you make more money. Do you spend more? Do you spend less? And lastly, we're going to talk about budget line graphs. I just thought this one was funny. One side is pizza, the other side is beer. Down here, you're not spending all your income. Over here, you're spending too much. Between those two things, what can you afford? What's my budget? That one's just silly, so don't take it seriously. Y'all, you cannot drink unless you're over the age of 21 in the United States of America. So none of y'all be drinking. I just thought it was funny because, I'm a jokester. Not encouraging, though. So what's my budget? We will eventually do that, but not today. We're going to do some examples still, and then we're going to formulate a budget. I know I've been saying that like every day, but like, I mean it. So first thing we're going to talk about is bar graphs. Here is an example of a bar graph. So the title of this bar graph is great. Y'all gonna make me. And then we have the category of lose my mind. Up in here or elsewhere. Go all out is another category. Act a fool is another category. Or lose my cool. I just thought this one was so stinking funny. I started almost crying, laughing so hard because I'm pretty sure isn't this DMX? Y'all gonna make me lose my mind. Up in here, up in here. If you don't know, you need to figure it out. Look on the YouTube, you'll find it. It's a good time. All right, so criterion of bar graphs. All laughs aside, a bar graph is used to depict categorical data. So the categories in this instance is lose my mind, go all out, act a fool, or lose my cool. And if I had two categories to compare, it would be up in here or elsewhere. The x-axis has the categorical data listed. So this is the categories, like the x-axis always usually has the categories. The y-axis typically has the amount or value. Now this one's not graph, but if this was like 1, 2, 3, 4, just any number, could be 100, 200, 300, 400, it could be anything. It could be 5, 10, 15, 20, doesn't matter. Usually there's labels on it though. And what you need in order to create a bar graph is the categories. You're also going to need the total amount in each category. And the reason being for that is because you need to figure out the range for the y-axis, like how high is this going to go up so we can have our labels. And additionally, based off of the amount in each category and the range, we need to figure out that scale for the y-axis. Cool. So, example 4. Construct a bar graph using the information about healthcare costs from sample B. So we talked about this last time we were here. Here is sample B. This is our just regular cost graph. So we want to construct a bar graph from this. So remember, first thing we need to figure out is the categories. So looking at this, what are the categories? So if I reread our graph here, we've got health, insurance, prescriptions, over-the-counter meds, doctor visits, life insurance, health club dues. Then we've got the month of January, February, March, April, May, all the way to December. So what do you think is going to be the categories? I'll give you a second. Is it going to be the rows, everything that goes horizontally, or is it going to be the columns vertically? Give you 5, 4, 3, 2, 1. It's going to be the months. So it's actually going to be the columns because we're comparing the total costs of these for each month. Each month stays consistent. So additionally, now that we know the categories that we're going to be comparing, I need to know the total amount in each category. So all we're going to do is they're conveniently listed in a column. So we're just going to add them up. We need to add up each and every single column. So for the January column, we have 30 plus 200, and that's going to give us 230. Moving into our next column, which is February, we're going to do 90 plus 30, which is 120. March is 450 plus 30. That gives us 480. April is 90 plus 50 plus 300, and that gives us 440. May, there's nothing but 50 in here, so that added up together is just 50. June, 450 plus 90 plus 50 more, that is giving us 590. July is 50 plus 200, leaving us with 250. August is 90 plus 50 plus 300, so I'm spending $440 in August. September is 450 plus 50 plus 600, that's $1,100. October is 90 plus 30, which is $120. November, we only have over-the-counter meds, so I only have a $30 cost. And December, I'm spending $450 plus 90 plus 30 plus 300, resulting in a total cost of $870. So I need those categories and I need the amount in each category because I'm essentially constructing the y-axis. So I've got my categories. I've got my total amount in each category. Now I have to decide what is the range. Looking at these amounts in these categories, it looks like the smallest amount I spend is 30, so it's got to have at least 30 in there, but might as well just start with 0. And looking, the largest amount that we have here is 1,100. So it needs to have at least $1,100. for the range. Otherwise, this bar graph is going to fall off. It's not even going to be visually depicted. So this guy I need to see the cap on this. So usually we pick a little bit larger value than the highest one. So I'm going to say like 1200. 1200 is good. So I'll be able to make sure that we can see September in its entire glory of a very expensive month for health. And lastly, we needed to figure out the scale. So when we're graphing, what's the scale going to look like? How can I represent this? And now the scale is usually totally up to you. Doesn't really matter. Your choice. Just make a sound choice. I'm going to say like about like increments of 200 or so. 100 might be pretty tedious. 500 seems to be a little bit too spaced out, especially considering with like, um, 30 and 50 and all of that. So if I were to make a little chart just to make it a little bit easier, I could say that January is 230, February is 120, so on and so forth. And as I create my bar graph, notice here's my categories: January, February, March, April, May, all the way across. Those are all of my categories on the x-axis. And then the amount on the y-axis, notice that it goes to 1200, which is more than the amount that I had. I can see September in all of its glory. And my range, 0, 200, 400, 600, 800, 1000, 1200. And then you just draw your bar graphs approximately where they are. So since January is 230, it's a little bit over 200, but not too much. February is only 120, so it's a little bit more than half. March is 480, so it's almost halfway between 400 and 600. April is a little bit less, so just a tiny smidge smaller, and so on and so forth to create a bar graph. Like I said, you guys should be pretty comfortable with this. And actually in today's assignment part of the hyperdoc, you guys are just going to use technology for it just because, I mean, why not? Why not, right? When we can use technology, why don't we go on ahead and use some technology? Yes, sir. All right. The next type of graph we can work with are line graphs. So I chose this image because one, I thought it was hilarious, and two, very prevalent for y'all. So again, this is a joke. Let me have my joke. But the x-axis is our categories. So for procrastination on homework, the categories are when it is given to you, after school, 8 p.m., 2 a.m., and the morning before school. And then the y-axis is measuring how much you're procrastinating on the homework. So at 0 is screw this, like you're not doing it at all. A little bit higher is it can wait. I had something to do. I should really do that homework. I should really do that homework. And oh shoot, oh shoot. So you notice when it's given, you're like, this can wait. After school, you're probably somewhere along the lines of, I have something to do. 8 p.m., you're like kind of in between, like you're like, oh, I should probably do that homework, and I really should. Maybe you just had dinner and you're, procrastinating. 2 a.m., you're saying, screw this, right? Between 8 p.m. and 2 a.m., you're thinking, oh, maybe I should do it. But at 2 a.m., you are sleeping. You said, nuh-uh. And then the morning before school, I've seen it happen. But none of my precious little angels, right? But I just thought it was funny. So we're going to kind of go over the same stuff for line graphs. A line graph is also used to depict categorical data, and it can compare multiple categories if you want it to. What I didn't mention before is that the bar graphs can totally depict multiple categories as well. You usually just have to color code them, and you would still present them right next to each other. The x-axis has the categorical data listed, same as the last time. The y-axis has the amount or value that you're placing. And what you need to determine for a line graph is the categories. Of course, we need the categories, the total amount in each category, the range for the y-axis, and the scale. So we literally need the same exact stuff, and you guys probably are even more comfortable with line graphs than you are bar graphs. They're essentially just a dot plot. That's all it is, and then you connect them with lines. Okay, so example 5. Over the last few months, Kate has spent more than her budgeted amount for her cell phone bill. Homegirl be talking. She decided to track her daily call usage in minutes to see if she should change plans. Girl, you probably should. If you're always going over it, you should change. She went online to her cell phone account and got the usage data below for the last 3 weeks. Or if Kate was smart, she would have the app and just look right on her phone. Whatever. Maybe Kate's a boomer. Who knows? Construct a multiple line graph to identify any of Kate's usage trends. So the reason why line graphs are cool is because you can use it to check out trends, and that's typically what it is. So when I showed the example last time, it was the trend of like your income versus your spending. Usually line graphs are used to see what kind of trends you have, and they're usually over long periods of time too. So you can have different lines for like, year 1, year 2, year 3 of like, if you're really serious about budgeting, you can create a line graph of like how much your budget was and like see the trends on if your budgets go up or down. You could take your actual spending and see the trends. Then you can start to infer and make changes and adjustments and save money in different places. But line graphs are really, really good for finding out usage trends. So let's see what's up with Kate. So the way this breaks down is she's looking at it in terms of weeks, week 1, week 2, week 3, and then the days of the week, she's breaking it down even further, and these are the minutes used. So Monday, she used 18 minutes on the first week, 10 minutes the second week, 13 minutes on the third. Tuesday, she spent 17 minutes on the phone, 19 and 12. Wednesday, 12, 15, 18. Thursday, 19, 20, 23. Friday, 24, 29, 40. Saturday, 35, 24, 30. Sunday, 30, 22, 27. So we're going to be comparing week 1, week 2, and week 3. So we can get the trend of like how much she's talking, because maybe that will give us some insight as to what kind of plan she might need. The categories are going to be the days of the week on the x-axis, since we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, like each broken up. And then the amount of minutes is going to be on the y-axis. And we're going to be comparing week 1, week 2, and week 3 side by side. So that's why I chose the categories to be the days of the week and not necessarily the week numbers. Lastly, the range is going to be 45-ish. Because the maximum number in here is 40. So remember, our range needs to be a little bit larger. So 45 around there sounds good. 50 might be a little bit of a stretch because it's a little too big. But I also noticed that like these numbers are even and odd, so probably increments of 5 will be the easiest. So 45. And our vertical scale, like I said, it's always up to you. I'm thinking increments of 5 since the values are varying. And a scale of 10 might be too large. I don't know why it didn't finish writing that in there. My bad. But yeah, I think a scale of 10 might be too big. In between. And in order to graph a line graph, you're going to create a blank graph with your labeled x-axis and y-axis. Then, like I said, it's a dot plot. Plot the dots for each data point in our chart. Be sure to make each week a different color since that's what we're comparing, or you could use like different levels of thickness if you wanted, but make sure you have a key for it. So I want you guys to go ahead, pause this video, and make your dot plot or your line graph for this. Do 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 do. Do 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 do. Ba da ba 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 ba. Okay. So here's our data. I really need to figure out how to embed like songs or little snippets of sound in here. That would make my presentations way cooler. So again, here's the data that we've got working with, and we just wanted to create a line graph. So like I said, x-axis is going to be our categories, which we said were days of the week. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Our y-axis is minutes used with increments of 5. So 5, 10, 15, 20, 25, 30, all the way to 45, right? And then we were comparing weeks. So like I said, different color for week 1, different color for week 2, different color for week 3. And as you would, week 1, right, this entire column. On Monday, you have 18 minutes, so a little bit below 20, plot. Week 2, 17, a little bit less, plot. Week 3, 12, plot. Week Thursday, 19, plot. Friday, 24, plot. Saturday, 35, plot. And Sunday, 30. And then you would connect those with lines and do that for each column for each week, week 1, week 2, and week 3. And you get something that looks a little bit like this, like so. So just looking at this, right, we want to notice trends. What do you guys notice? Take a second, think about what do you notice based on this graph. All right, so let's talk about it. We can visually see what's nice about this is it gives us a nice visual representation that homegirl talks a lot on Friday. And yeah, we kind of could see that right here, but it's very apparent that like she talks a lot on Fridays. And considerably more. This part of the graph is way higher up on the minutes used on the weekend. So Friday, Saturdays, and Sundays, homegirl talks a lot. So she uses a lot of minutes on those weekends. And she also has the highest number of calls on Friday with this giant peak here. So, or length of time on the phone. So, knowing this information, what can we tell her about her phone plan? Well, she should look for a cell phone plan that has like weekend plans, like weekend minutes, like unlimited. Back in my day, you used to get weekends free. And there used to also be a thing where like if you called someone with the same uh carrier as you, like Verizon to Verizon, you would get free minutes, and then like after 8 p.m. there would be free minutes. Now I think they're mostly unlimited, or like you just buy a set amount, but you never know. So she should look for a cell phone plan that offers a weekend one, and then compare the costs and see if she can save some money since that's when she's typically using it. Yeah, feel ya dig. Yeah, I don't know if they still do that. They've got to. I don't know. Cell phones are such a hot commodity now. Like 10 years ago, that was not the story. People were starting to get them. So crazy. Time is crazy. All right, and the last one, budget line graphs. I showed you guys this image before, but I still really like it because I think it just gives a really nice visual to it. A budget line separates what's affordable and what is not. So we're going to develop a budget line. Usually it's comparing two different things. So like this axis is books and this axis is movies. It's usually comparing two goods that like you enjoy spending on, and then you figure out a budget between the two. Sometimes it's something that is completely the same. Like in today's example, like the same category. So this could have been like, I don't know, like your favorite antique bookstore versus Barnes and Nobles, or this one could be like movie theater versus purchasing a movie off Vudu or something like that. But we end up coming with a budget line cost function, and we graph it, and it's always a line. Okay, so we have a line here, and then anything below it means you're below your budget, you're in an affordable range. Anything above your budget means you're over budget, literally, so you're not in an affordable range. A budget line graph is a graph that visually represents spending between two or more expenses. There can be more. You can have multiple lines on there. You can look at intersections and things like that, but we're just going to do kind of like the basic budget line graphs. And this also goes into optimization a little bit. So in optimization, there's a lot of different constraints that you can add that you're trying to optimize. Again, the region below the line or the line segments with whatever you're working at is always what's most affordable. And there's actually a specific spot that is the most optimal for business, which is really cool. The area, again, below the line represents staying under budget. The line itself means you're spending exactly what you said you would. You're expending exactly whatever your budget is. You're not going over, you're not going under. You spent exactly what you said your budget was. and the area above the line represents going over budget. Sometimes it's a little over budget, sometimes it's way over budget. So like if your line was right here, your dot was right here where my laser pointer is, you're just a little bit over budget. If your dot was way over here, girl, you way over budget. Even right here, that's still pretty far over budget. So what you need to determine with our budget line graphs, the hardest part is coming up with the budget line equation, and it's still not even that bad because it's a line, y'all. Then we have to graph it. Again, not hard because it's a line. And then we just need to see, like, are we above budget? Are we at our budget? Are we over our budget? Need to be able to determine that. So that's what we gonna do. So here's our next example. Beth is a coffee lover. In her budget, she's such a coffee lover that Beth has a category for coffee built into a budget, all right? She is on one. She has budgeted $90 a month to spend on coffee that she buys at 2 specific locations. So not only is she a coffee lover, right? So much so that she has a budget for it, but she's a coffee snob. It sounds like she only goes to 2 different places, and she's going to spend dang near $100 a month on her coffee. So the 2 different locations she has is at Gas Mart. Her cup of coffee costs her $1. And then she goes also to the Perfect Coffee Company, where a cup of coffee costs her $3. Because of the cost, she tries to go back and forth between the 2 per month. She alternates throughout them. She doesn't continually go to the Perfect Coffee Company 7 days a week because that's more expensive. So sometimes she'll go to Gas Mart, sometimes she'll go to Perfect Coffee Company, just depending maybe the mood. But she tries to always alternate because of the cost. So our goal is to construct a budget line graph that shows the different combinations of the coffee purchase options that would allow her to stay within her budget. Then suppose she has to decrease her coffee by 20%, identify and graph the new budget line. So we got a situation here, y'all. We have got Beth, right? Beth. Insert Beth. This is Beth. Her Insta bio says #coffee enthusiast. I'm just roasting her. Get it, roasting her a little bit right now, just for fun. To recap, this is Beth. Her Insta bio says coffee enthusiast. Here is her $1 cup of coffee from Gas Mart, which I'm assuming is like gas station or something. She's found like the key to gas station coffee. And then here's her other favorite coffee place, the Perfect Coffee Company, for $3 a cup of coffee. She's got to get that latte art in her Instagram. You know what I'm saying? She's got to let everyone know #coffee enthusiast. And also, here's how extra Beth is. Here's her budget for coffee, $90. This is very Instagram aesthetic. It's kind of masculine. She's got her phone out. She's got her budget, a black cup of coffee, and of course a tree. But in all seriousness, let's figure out her budget line graph, and figure out some combinations that are going to allow her to stay within her budget. So at the side, let's do some calculations for her. So the 2 items, X and Y, are budgeted in a single category. So that category being coffee. And their cost per item are going to be C sub X and C sub Y. Basically, we're just going to say like X is it's either going to be the Perfect Coffee Company or Gas Mart. And then it's going to be the cost for going there and the cost for going to the other location. So we're going to end up with this equation. The cost of one times the amount plus the cost of the other times the amount equals B, which is the budget. This is just a fancy way of saying like a cost times X plus a cost times Y equals my budget for 2 different locations, location X and location Y. We're going to make it relative here. So let X represent the number of cups of coffee she purchases at Gas Mart, and let Y represent cups purchased at the Perfect Coffee Company. Okay, like X comes first. The first thing that comes up in the equation is Gas Mart for $1, and then The second one that comes up is Y, and that's the perfect coffee company, right? So X represents the number of cups she's going to buy, and Y is going to represent the number of cups she's going to buy. And then C of X means the cost at Gas Mart. Gas Mart, how much does a cup of coffee cost? It costs us a whole dollar. So we're going to plug in 1 for C of X. And then the cost at the perfect coffee company is $3. So we're going to plug in 3 for C of Y. Right? So C of X is equal to 1 because the cost of a cup of coffee is $1 at Gas Mart, and C of Y is going to be $3 because the cost of her cup of coffee at the Perfect Coffee Company is $3. And lastly, her budget is $90, so we have to set it equal to 90. She's not going to spend any more than 90. That's what she's figured out in her budget, how much she can spend maximum on coffee each month. So if I do take this original equation, and I substitute in C sub X is 1, C sub Y is 3, and B equals 90, I get the following. I have my equation, and plugging them in, I get 1 times X is just X, plus 3 times Y equals 90. So I get X plus 3Y equals 90. Easy enough. It's literally easier than you think. This kind of makes it seem a little bit more dramatic than it is. But it's really, really not too simple or not too difficult. Okay, then we have to graph this. So we got to solve for Y. Subtract X from both sides. And if I did that here, let me do it. If I did minus X minus X, we end up with 3Y equals negative X plus 90. The next part we still got to solve for Y is to divide each side by 3, which would mean divide by 3. Sorry, I'm trying to do this with a mouse. It is really challenging. And we would end up getting Y equals negative 1/3 X plus 30, because 3 goes into 93 times, 30 times. Okay, cool. This right here is our budget line equation. Again, it's a line. It's no big deal. We're going to use this because our goal right now is to construct a budget line graph that shows the options we have. So we need this. So we just have to graph our budget line equation. Again, this is a line. This is light work, people. This is so easy peasy lemon squeezy. It's not even funny. Because looking at our budget line equation, this guy right here, we know that the y-intercept is 30, right? Y equals mx plus b. M is our slope, x, and then plus b. B is our y-intercept. And then we also know that our slope is negative 1/3, down 1/3, rise over run, right? So let's go. Let's graph this baby. No big deal. Okay. I'm keeping this for something specific. This was the original budget equation that we started off with, and we just wrote it in terms of Y. So this was the OGBE, original budget equation. And then we just wrote it in slope intercept form. F. Slope intercept form, right? That's our budget equation that we're working with. So we graph it, right? We have Gas Mart Coffee on one axis. We have Perfect Coffee Co. on the y-axis, right? And then negative 1/3 x plus 30, we would mark our y-intercept at 30. Boom. And then you go down 1/3 to scale, and we end up getting this bad boy right here, right? Beautiful. So we have this, and we have a couple options that I just randomly selected some points, right? I selected point A over here, boom, point B over here, boom, point C over here, boom, right? Because we did the budget line graph, and we have to show a couple combinations that stay within budget. So we have 3 different points that I want to talk to you guys about. Notice, take your eyes over to point A. Point A, below the budget line. I want to change colors here. Point A. Right. Oof. right below the budget line. Point A, right? Below the budget line. This is in the feasible region. This is below budget. So if I were to interpret this specific point down here, and we can do this with any point below the budget, that just means, oof, where am I? Below the budget, hold on, let me get my laser pointer. Here, right? Notice that X is Gasmark coffee. So 20 cups of Gasmark coffee, and then my y-axis 6 cups of Perfect Coffee Company. The Perfect Coffee Company would be within budget. So, right, interpreting these points, this is 20 cups of coffee from the Gas Mart, and then this is 6 cups of coffee from the Perfect Coffee Co. Right? Any point you could have selected this one. This would be 40 cups of coffee from Gasmart and 10 cups of coffee from Perfect Coffee Co. That is also within budget. I could have went way over here to have been no cups of Gasmart coffee, but 25 cups of the Perfect Coffee Co. And I would still be within my budget, right? I could choose something crazy like this. Like this could be looks like 14 cups at the Gasmart and 22 or 21 cups at the Perfect Coffee Co. Anything in here is going to be feasible within region, right? So to show you mathematically from my original cost function, that's why I have this original budget equation, 20 times 1, the amount of cups for point A, 20, plus 3 times the amount of cups here, which is 6, gives me less than 90. That means I'm within my budget because my budget was $90 originally. Now, bring your eyes to point B, right here, right on the budget line. This is still doable, right? But this means I'm exactly at my budget. So if I interpret this point, I notice that on my x-axis, that is Gasmark coffee. So I have 60 cups of Gasmark coffee and 10 cups of Perfect Coffee Co. That's a lot of coffee. That's 70 cups of coffee in 1 month. That's crazy. Um, but I mean, technically, she's still exactly on budget. Mathematically, $60 times 1 plus 10 times 3 does exactly equal 90. 60 plus 30 is $90. So she's absolutely still on budget, but homegirl's drinking a lot of coffee. Point C, or anything above here, is going to be over the budget. It's literally over the budget line. That's how it's over the budget. It is not feasible. It's going to be way more than $90. So this point right here is at $40 on the x-axis. So she's drinking 40 cups of Gas Market coffee and 25 cups of Perfect Coffee Co. That's way too many. She's spending way more. She's overspending. She's not in her budget anymore, which means somewhere else in her budget, she's going to have to cut back. If she was really, really specific on her budget. Or she might be spending less, putting less into savings that month. So mathematically, 20 times 1 plus 6 times 3 is over $90. So she's, pardon me, over budget, right? This isn't too bad. It really ain't. And the last part of this question says, suppose she has to decrease her coffee budget. She, starts getting her student loan payments come in. They roll in, and she's like, "Oh shoot, I need to start paying those off." So after evaluating, she's like, "Okay, I can cut back on my coffee by 20% because I'm a little excessive." And maybe she noticed she hasn't been reaching her budget. She's always been under budget, so she is decreasing her coffee budget by 20%. Identify and graph the new budget line. So we just have to come up with a new budget equation and then graph it. So if Beth has to decrease her $90 budget by 20%, we just need to go back to the original cost function and change this amount on the right? Because it's still going to be $1 for Gasmark coffee, and it's still going to be $3 for the Perfect Coffee Co. The only constraint that's changing is how much she's saying that she's able to spend. So we're going to change just the right-hand side. A 20% decrease is the same as multiplying by 80% because 100% minus 80 is 20, and she's decreasing by 20%. So to figure that out, how much this number is going to change, we're going to multiply 0.80 times 20. We get $72. So now her new budget is $72, and therefore our new equation is x plus 3y equals 72. rewriting this in terms of y, we get negative 1/3 x plus 24. So we created our new budget equation. Now we just have to graph it with a y-intercept of 24 and a slope still of down 1/3, negative 1/3. And here we are. Okay, here was our original cost function. Here's 24, down 1/1, 2, 3 to scale, and there we go, right? This is my new budget line. This was my original. This is my new budget line, and this is where we are. Now, notice, like, obviously we're decreasing our budget, but something I want you guys to see is this also affects the numbers of combinations. So, like, I can have 30 cups of Gas Mart coffee, but the maximum number of but if I'm right on my line, I can only have 14 cups from Perfect Coffee Co. So it just performs a restriction. You have less range on the X and Y area. So I can only go from 0 to a little like 72 on the X, whereas originally I could go all the way up to 90 cups, and 0 to 24, whereas originally I could have 0 to 30 cups. So cool. Cool. That is it, you guys. We will be doing some more in terms of budgeting, but today I just wanted to give you guys like the breakdown of how we interpret graphs, because I feel like that's the most important, and we will soon enough create our own budget. So I hope you guys have a wonderful rest of your day. Let me know if you thought my video was funny. I thought it was. I'm just trying to have a little bit of fun. You hear? All right, and I will see you guys next time. Peace.